Hello and welcome to my first video. This video is for Chapter 2 Advanced Geometry, Section 1, which is on conditional statements. If at any point you need to stop the video so that you can write down any of the information, I recommend you do that. I might move more quickly than what you can copy down just because I want to make sure that I go over stuff and you don't have to wait for me. Okay, so first we have a conditional. A conditional is another name for an if-then statement. So for example, if you are not satisfied, your money will be refunded. There are two parts to a conditional statement. First you have the hypothesis, which is the part of the conditional following the if. Now please don't think that has to be at the beginning of the sentence. We can also write something like, I will go to the movies if I have enough money. And this part right here is the hypothesis, if I had enough money. The conclusion is the part of the conditional following the then. Now in this case, for the example I wrote, it's kind of implied, then I will go to the movies. So here's an example. Identify the hypothesis and conclusion of this conditional statement. If Texas won the 2006 Rose Bowl football game, then Texas was college football's 2005 national champion. Easiest thing to do is to find the if it's present. It doesn't always have to be there. Or find the part that is, the beginning. What are we saying first and then what's following? So if Texas won the 2006 Rose Bowl football game, that's going to be our hypothesis. So our hypothesis is Texas won the 2006 Rose Bowl. And then our conclusion is then Texas was college football's 2005 national champion. So our conclusion is Texas was the 2005 college football national champion. Now a conditional can be true, a conditional can be false. We can also have the hypothesis be true or false, or the conclusion can also be true or false, and we'll be looking at those in a little bit. Okay, so write a conditional from the basic statement. So this statement doesn't have an if-then. They want us to turn it into an if-then conditional statement. A rectangle has 4 right angles. Now in this case, they don't tell me what the figure is, so I'm going to have to add some words. So I might write something like, if a figure is a rectangle, then it has 4 right angles. And the second one is a tiger is an animal. So if an organism, or whatever you want to call it, if an organism is a tiger, then it is an animal. Okay. Now, like I mentioned before, a conditional has a truth value, and it can have a truth value of either true or false. Show this conditional is false by finding a counterexample. If it is February, there are only 28 days. So all we have to do is figure out a February that doesn't have 28 days, and we can show that this conditional is false. So if we pick any leap year, that would be a counterexample. Any leap year is going to have 29 days. We can also draw a Venn diagram. So Venn diagrams are really useful for demonstrating the relationship between different things. So if you live in Chicago, then you live in Illinois. So first we have to decide, are we going to use circles, or you can use rectangles. I'll use circles. And then we have one basic idea of Chicago, and then we have another idea of Illinois, and we have to figure out, well, if you live in Chicago, do you live in Illinois, or do you live in Illinois, you're in Chicago? So if you live in Chicago, then you are Illinois. That means that Chicago should be inside Illinois. We can also look at things like, does it always have to be true? Is it sometimes true? Things like that, and we can combine different Venn diagrams and illustrations. Okay. Converse. So the converse of a conditional statement is when you switch the hypothesis and conclusion. So converse is you switch the hypothesis and conclusion. So for example, write the converse of the following conditional. If two lines intersect to form right angles, they are perpendicular. So I'm just going to take these two statements and switch them. And so if two lines are perpendicular, then they intersect to form right angles. Okay. And one of the things we're going to be looking at in the next section is just because the conditional is true doesn't mean the converse is true. If two lines intersect to form right angles, they are perpendicular. That's a true statement. If two lines are perpendicular, they intersect to form right angles. That's also true. So in this case, not only is the conditional true, but the converse is also a true statement. Okay. So finding the truth value of a converse. Which conditional statement has a false converse? So the first one says, if two planes are parallel, they have no points in common. The converse would be, if two planes have no points in common, then they are parallel. In this case, that's a true statement, and the converse is also true. If a figure is a square, then it has four sides. The converse would be, if it has four sides, then the figure is a square. So now if you think about that, not just because it has four sides does it make it a square. We could just have a rhombus. We could also have any quadrilateral. So in this case, this one is false. Just to check my answer, I'm going to go through and do the last two. If a point has an x-coordinate of 0, then it lies on the y-axis. The converse would be, if a point lies on the y-axis, it has an x-coordinate of 0. That's true. And if two angles are congruent, they have the same measure. If two angles have the same measure, they are congruent. That is also true. So this one is true, and the converse is true. And this one is true, and the converse is also true. So I'm pretty comfortable my answer was B. Okay. The next problem 7 we're actually going to talk about in class because it's a great problem. So read it over, take a look at it, have an idea, and we'll discuss it in class. So the next thing I have is it's kind of like a summary, and it also does put something new here, and this is called symbolic form. So what we've learned today is we have a conditional, which is an if-then statement, and we can also do the converse, where we switch the hypothesis and the conclusion. Now, this symbolic form, P is normally used for the hypothesis, and Q is normally the letter used for the conclusion. And then we have an arrow to denote, it's basically like a therefore or a then. So you can write, some people say P therefore Q or Q therefore P, or you can also read as a conditional, if P then Q. So the little arrow is basically like an implies kind of thing. Okay. So the first one is saying if P then Q, and then this one down here is saying if Q then P. And that ends my first video. So thank you for watching my video, and we'll go over that one question in class, and I'll see if you have any questions on the notes, and then we'll do some work in class practicing.